Hi everyone, IBM is my name. I'm back with the last episode of uncertainties. This is the last episode of errors and uncertainties, and this is the last part of solved past paper questions. This is part 3. This is a continuation of yesterday's video. Yesterday was supposed to be the last part, but then the device failed. Therefore, I decided to finish the last part of uncertainties. I am trying to do this to make sure that you gain a lot of confidence in dealing with uncertainties. So yesterday my device broke up, or it stopped when I was on question number 37, and therefore I want us to start from question number 37. So question number 37, a steel wire is stretched in an experiment to determine the Young modulus for steel. The uncertainty in the measurements are given below, so we saw that these uncertainties were given. What is the percentage uncertainty in the Young modulus? First of all, we saw that Young modulus is equal to stress divided by strain, but stress was actually force over cross-sectional area, and strain was extension of original length. So when we get the reciprocal, it will be actually original length divided by extension. But then we also saw that the area, because they had given us the diameter, the area was given by pi d squared. This is over 4. That means the Young modulus would precisely be the force over area. I'm dividing the area, the force by the area, so that gives us 4F, because the 4 goes up, times L naught divided by pi d squared times E. So they want the percentage uncertainty, so without wasting time, we can find the percentage uncertainty. So we shall say the percentage uncertainty in E is equal to, of course, the constant 4 and pi will not affect the uncertainty. So this will be percentage uncertainty in F plus percentage uncertainty in L plus percentage uncertainty in E plus twice the percentage uncertainty in D. When we substitute our values that have been given for F they have given us the load as 2, so that will be 2%. Then for L naught, for the length they have given us 0.2%. And then for E they have given us 1%, then plus twice the percentage of D, which is 1.5%. 1.5%. So when you add 2 plus 0. That is 2.2, 3.2 plus 3, that is 6.2. So percentage uncertainty in E, the percentage uncertainty in Young modulus is actually 6.2%. That makes our answer to be D. So without wasting time, I don't want this video to be long today. I want it to be very short. The diagram shows part of a thermometer. What is the correct reading on the thermometer and the uncertainty in the reading? So one, you see that the divisions are fairly large enough. Therefore, the uncertainty in this can be approximately half a division. So the answer, we get the value of one division. So we have 25. This is 25 minus 20 divided by 5 divisions. Each division is 1 degree Celsius. And then half a division, it means the absolute uncertainty in temperature here is going to be half a division, which is plus or minus 0.5 degrees Celsius. So we have eliminated A and we have eliminated C. But then the absolute uncertainty here is 1 decimal place. That means the true value should also be to 1 decimal place. So when we look at these two values, you see that this is given as a whole number, yet this is 1 decimal place. So this makes our answer to be D. I hope that is home and dry. Next. The resistance of a thermometer is determined. The current I in the resistor and the potential difference V across it are measured. The results were with their uncertainties are, they have given us I, they have given us V. The value of R is calculated to be 7.5 ohms. What is the uncertainty in this value of R? So we know that R resistance is going to be V over I. Because of division, we add the fractional or percentage uncertainties. Since they have given us absolutes, then we shall say that the fractional uncertainty in R is equal to the fractional uncertainty in V plus the fractional uncertainty in I. So that means the absolute in R is going to be equal to, do we have the true value of R? Yes, it is 7.5. So this will be 0.5 divided by 15.0 plus, this is going to be 0.2 divided by 2.0. All this must be multiplied by the true value of R, which is 7.5. So let's press our calculator very fast. Open the bracket, 0.5 divided by 15.0 plus, open another bracket, 0.2 divided by 2.0, close that bracket, times 7.5. And this is giving me 1. This is giving me exactly 1. So the question is, what's the uncertainty in the value of R? And I'm getting plus or minus 1. Exactly. So this is plus or minus 1 ohm. So that means the answer will be D. You can also check, maybe I've pressed my calculator wrongly, but I guess that is true. Next. In an experiment to determine the acceleration of free fall G, the period of oscillation T, and the length L of a simple pendulum were measured. The uncertainty in the measurement of L is estimated to be 4%. So in L, the uncertainty is 4%, and the uncertainty in T is 1%. The value of G is determined using that formula. What is the uncertainty in the calculated value of G? So we see that the answers are percentages, so we shall not waste time. We shall just deal with the percentages. So percentage uncertainty in G is equal to, we ignore the constants, 4 pi squared will be ignored. This will be percentage uncertainty in L plus, because T is squared, so this will be twice percentage uncertainty in T. So we substitute quantities, so this will be equal to L. L has been given as 4% plus twice. T has been given as 1%. Sorry, so this is 1%. 1%. So this is 4 plus 6, plus 2, which gives us 6%. So the uncertainty in G is going to be actually 6%. Next. The mass of a cube of aluminium is found to be 50 grams. Mass 50 grams. Uncertainty 10 grams. So it is 580 grams plus or minus 10 grams. Each side of a cube, we know a cube has all sides equal. Each side has that. Calculate the density with its uncertainty. So let's see. We know that density is equal to mass over volume. We don't have the uncertainty in volume, but it is a cube which has all sides equal. So the volume is going to be side times side times side, which is side cubed. As simple as that. Therefore, we shall say that the density is equal to mass over side cubed, or L cubed, or the length cubed. So we can substitute, because the answer is needed in grams per centimeters cubed. We don't need to worry. So the density is going to be equal to the mass, which is 580 grams, divided by the side, or the length of the side, which is 6 cubed. We press our calculator. That is 580 580 divided by 580 divided by 6 cubed, and we are getting the density. Of course, this is centimeters cubed. We are getting the density as 2.685. I will stop there. That is what I'm getting as the density in grams per centimeters cubed. But then I'm interested in the absolute uncertainty. So let's find the absolute uncertainty. Because they have given us in mass and in S, then absolute uncertainty in density is going to be equal to the absolute uncertainty in mass divided by the mass, that is the fractional, plus 3 times the absolute uncertainty in S over S. I will multiply this by the true value of rho because we are adding the fractional uncertainties. So this will be equal to, for mass, that is 10 grams divided by 580 grams, the grams will cancel, plus 3 times 0.1 divided by 6.0. Then we shall multiply this by the true value of density times 2.685. So when we press our calculator, 10 divided by 580 plus 0.3 divided by 6, multiply this by 2.685. So I am getting my absolute uncertainty as 0.18. So this is 0.18. 180. I will stop there. To one significant figure, this is approximately 0.2. Of course, it has the same unit, grams per centimeters cubed. But to one significant figure, it is one decimal place. So I will go back and rewrite this to one decimal place. So the final answer becomes 2.7, one decimal place, plus or minus 0.2. As simple as that. Next. The student finds the density of a liquid by measuring its mass and its volume. The following is a summary of his measurements: mass of the empty beaker, mass of the beaker plus the liquid, volume of the liquid. He correctly calculates the density of the liquid to be that. What is the uncertainty in this value? So density of the liquid is going to be the mass divided by the volume. We have the volume of the liquid, and all we need is the mass of the liquid. So the mass is going to be the mass of the beaker plus the liquid minus the mass of the empty beaker. So the mass is actually 70 minus 20, which is 50 grams. That is the mass. But then what is very important is the uncertainty. When we subtract the masses, we cannot subtract the uncertainties. The uncertainties, when quantities are subtracted, the uncertainties add up. They simply accumulate. So the uncertainty in this reading and the uncertainty in this reading, when we subtract the two readings, the absolute uncertainty in the measured value of mass is actually going to be 2 plus or minus 2 grams. In fact, we are saying that the mass will be, the difference in the mass is going to be, the mass is going to be 50 grams plus or minus 2 grams. That is the mass. The question is, what is the uncertainty in this value, in the value of density? So the absolute uncertainty in density is going to be called the absolute uncertainty in mass divided by m plus, they have given us the uncertainty in volume, so I'll say the absolute uncertainty in volume divided by volume. Then the whole of this, I'll multiply it by the true value of the density. So I'm now substituting. The absolute uncertainty in density is going to be for mass, which is 2 divided by 50 plus For volume, which is 0.6 divided by 10, this is times the true value of density, which is 5.0. Let's press our calculator. Open brackets, 2 divided by 50 plus open brackets 0.6 divided by 10, then times 5. So this is 0.5. The absolute uncertainty here is 0.5. So this is 0.5. The units will be grams per centimeters cubed. That means our answer will be B. Next. Measurements made for a sample of metal wire are shown. They gave us the length, diameter, resistance. Show that the resistivity of the metal is calculated to be that. I think resistivity is now very easy. From resistance is equal to rho L over cross-sectional area. Then we make resistivity the subject. Resistivity is going to be equal to resistance times cross-sectional area over L. Then area, they have given us diameter. Area is pi d squared over 4. Then we substitute. So resistivity is going to be equal to 4. No, not 4. I'm substituting for the area. So this will be pi, actually not 4. Pi d squared times r divided by 4 times L. So that will be the density, the resistivity rho. You know, rho is used for density, also for resistivity. So this, by substitution, this will be pi times d. D is 0.38 times 10 power negative 3 to change it to meters, but is squared, times resistance, which is 7.5 ohms, divided by 4 times the length, which is 1750 millimeters, becomes 1.75 in meters. All that remains is to press the calculator. Shift pi times, let me say 7.5 times open brackets 0.38 exponent negative 3, but this is squared, divide by open brackets 4 times 1.75, close the brackets. So I am getting my resistivity as 4.860 times 10 power negative 7 ohm meters as required. Now, normally, sometimes we decide to forge because they have told us to show something. We decide to forge without checking our substitution. We just say that it is equal to what has already been given. That one, the examiner does not consider that. The examiner will go through your substitution and see if it leads to the question, to the answer being given. So you need to be very careful with your substitution. Okay, so I think the next part of the question may need us to find the uncertainty. So we know we have come up with an expression that resistivity is pi d squared r over 4L. And they have given us in length. Length is 1750 plus or minus 3. Check that the diameter d is 0.38 plus or minus 0.01. Also, they have given us the resistance as 7.5 plus or minus 0.2 ohms. So in our next question, I expect that we may be asked to find the absolute uncertainty. Let's check. Calculate the uncertainty in the resistivity. So we now know the formula that we have used. Resistivity is equal to pi, resistivity is equal to pi d squared times resistance divided by 4L. We want absolute uncertainty. We are going to ignore the constants because we see multiplication, division, and the power. So The absolute uncertainty in resistivity will be equal to twice absolute in diameter over D plus absolute in R over R plus absolute in L over L. This is times the value of the resistivity that we have already obtained. So we are now substituting. The absolute in resistivity is going to be equal to twice. In D, I think in D we had 0.01 divided by 0.38 plus in R we have 0.2 divided by 7.5 plus in L we have 5. Was it 5 or it was 3? This I don't remember. In L it is 3. So in L we have 3 divided by 1750. Note that I am not bothered with changing units because I'm dividing quantities with the same units. Therefore, the units always cancel out. But when I was finding the true value of rho, I had to change the units so that I could have or I could work out in the SI units. So this is times 4.86 times 10 power negative 7 as the true value of rho. Let's pick our calculator, open the brackets, 0.02 divided by 0.38 plus, open another bracket, 0.2 divided by 7.5, close that bracket, plus, open another one, 0.3 divided by 1750, close that bracket, times 4.86 exponent negative 7. So my calculator is giving me, you can also check yours. So my calculator is giving me the absolute uncertainty as plus or minus. This is 3.9, let me stop at 4, times 10 power negative 8. But I have been seeing that always ensure that the power of 10 in the absolute uncertainty looks the same as the power of 10 in the true value. Since the power of 10, the true value is negative 7, we are going to move one step to the left so that it becomes 0.394 times 10 power negative 7. Remember, when you move to the left, you add 1 onto the power of 10. Now to one significant figure, but anyway, in this part, I can even write 0.394 times 10 power negative 7. But remember, to one significant figure, because uncertainties are good enough to one significant figure. This is approximately 0.4 times 10 power negative 7. So in this last part here where they tell you to write this, notice that this is in one significant figure, it is to one decimal place, that is 0.4. Okay. Then this one should also be to one decimal place, so it becomes 4.9. Then I'll put a bracket times 10 power negative 7. So this is the most appropriate way of writing the answer. 4.9 plus or minus 0.4 times 10 power negative 7. Okay, I hope that is home and dry. That is very simple. Question 43, I think it's almost the third last. The volume V of a liquid flowing in a time t through a pipe of radius r is given by that equation, where P is the pressure between the ends of the pipe of length L and C depends on the frictional effects of the liquid. An experiment is performed to determine C. The measurements made are shown. Okay, so calculate C. To calculate C, I'm going to make C the subject. Where should I write? The space is too small, but it's fine. I'm making C the subject from that above equation. So this means I will have V over T times 8 CL is equal to pi times P R power 4. So C is going to be pi P r power 4 divided by v over t times 8L. So I'm substituting now. I'm going to substitute in C equals to pi p r power 4 divided by v over t times 8L. Substituting, so I have pi times p. P is given as 2.50 times 10 power 3. Then R has been given as 0.75 times 10 power negative 3. Because this is in millimeters, this is raised to power 3. Then this is divided by V over T. V over T has been given as 1.20 times 10 power negative 6. Then times 8 times L. L has been given as 0.250. It is in SI units. So what remains is to press our calculator. Remember, this is pi. I think I've written it very poorly. This is pi. Sorry. So pi multiplied by 2.5 exponent 3 multiplied by 0.75 exponent negative 3 divided by, open brackets, 8 times 0.25 and 1.2 exponent negative 6. So note very carefully that this has 1.2 has been raised to 10 power, has been multiplied, or should be multiplied by 10 power negative 6. So my calculation is giving me C. My calculation is giving me C as 2.4. No. Okay, 2.454. I will stop there, times 10 power 3, 6 times 10 power 6. I can cross check again. You can also cross check. You can multiply again and see. P is times 10 power 3. Yet R, oh, sorry. R is raised to power 4. So I have to raise this to power 4. Sorry about that. I had not seen that. So I will begin with the one which is raised to power 4, 0.75 exponent negative 3 raised to power 4. Then times 2.5 exponent 3. Then I multiply this by pi. Then I divide by 8 times 0.25 times 1.2 exponent negative 6. Yeah, so this is not true. So this is 1.035. I will stop at 4 times 10 power negative 3. So that is the value of C. So note the formula that C is pi times P r power 4 divided by V over T times 8L. And we have got C as 1.0354 times 10 power negative 3. Because I expect our next question to be asking us to find the absolute uncertainty, maybe. The absolute uncertainty. So we need to note these values here, the values on this page. For V over T is 1.2 plus or minus 0.01. Then for P is plus 2.5 plus or minus 0.05. Then for R it's 0.75 plus or minus 0.01. And for L it is 0.250 plus or minus 0.01. 01. So we need to have these values so that we shall be using them in the next page. Let's check. So we have finished to find our value of C. I think our value of C was 1.0354 times 10 power negative 3. Calculate the uncertainty in C. The uncertainty in C, I think by this time this is supposed to be very easy. We have a formula that C is equal to pi times P R power 4 divided by V over T times 8L. Some of you may be wondering why I did not separate V over T. The question in the table gave us V over T as one quantity. Now separating it again brings more challenges, but maintaining it makes life very easy. So we are going to ignore the constant pi and 8. They will not affect the uncertainties. So we shall say the absolute uncertainty in C will be equal to that in P divided by P plus 4 times, because R is raised to power 4. So that will be 4 times the absolute in R divided by R plus the absolute in L divided by L plus the absolute in V over T divided by V over T as one quantity. Then I will multiply this by the true value of C. Now I'm substituting. The absolute uncertainty in C is going to be equal to in P it is 0.05. You can always check on the previous page. 0.05 divided by 2.50 plus 4 times R, which is 0.01 divided by 0.75, then plus L, which is 0.01 divided by 0.250 plus for V over T, which is 0.01 divided by 1.20. Now I want you to note that when I'm finding the absolute uncertainties in C, I didn't include the powers of V over T and I didn't include the powers of P, because I know they will still cancel out each other. The power is on the numerator and the denominator. Then times my value of C, which is 1.0354 times 10 power negative 3. Let's try to press our calculator. 0.05 divided by 2.5 plus 0.04 divided by 0.75 plus 0.001 divided by 0.250 plus 0.01 divided by 1.20. Close the brackets times our answer 1.0354 exponent negative 3. So I am getting my absolute uncertainty in C as 8.8 7 times 10 power negative 5. So that one is accepted here. It can still be 8.87 times 10 power negative 5. But the next part of the question will not accept this value here. The next part says state the value of C and its uncertainty to the appropriate number of significant figures. 1. We must ensure that the power of 10 of the absolute uncertainty is the same as the power of 10 of the true value. Note that the true value is 10 to power 3. We must also ensure that this one is also 10 to power 3. How do I do that? I'll move 2 steps to the left. So it becomes 0.0887 times 10 power negative 3. When I move 2 steps to the left, it becomes, I add plus 2 on the power of 10, which was negative 5, it becomes negative 3. To one significant figure, this becomes 0.09 times 10 power negative 3 to one significant figure. I want you to note that to one significant figure, there are now 2 decimal places. 2 decimal places. So I'll write my true value also to 2 decimal places. So my true value will be actually 1.04. Then plus or minus 0.09. Then I'll put a bracket times 10 power negative 3. So that will be my value of C with its absolute uncertainty. You can check my computation using your calculator. Maybe there could be an error, but I hope I've tried my level best. Next, a micrometer is used to measure the diameters of 2 cylinders. The diameter of the first is that, the diameter of the second is 16.24, plus or minus, this is 0.03 millimeters. The difference in the diameter is calculated. What's the uncertainty in this difference? First of all, let's find the difference in the diameter. What is the difference? The difference we subtract. That is 16.24 minus 12.78. The difference is subtracting. Do we also subtract the uncertainty? No. The teacher said we never subtract uncertainties. Uncertainties are simply added up. Although the difference, we subtract it, and the difference will be 3.46. We cannot subtract the uncertainties. We simply add the absolute uncertainties. So the uncertainty in the difference of the diameter is going to be 0.02 plus 0.0503, which gives us 0.05. That means our answer will be D. And lastly, the speed of a car is calculated from measurements of the distance traveled and the time taken. The distance is measured as 200 with an uncertainty of plus or minus 2 meters. Time is 10 with an uncertainty of plus or minus 0.2. What is the percentage uncertainty in the calculated value of speed? So we know that speed is equal to the distance divided by time. Because of division, we can simply add the percentage uncertainties of each quantity. But we have absolutes, so we can even say absolute in S over S is equal to the absolute in D over D plus the absolute in T over T. When I multiply both sides by 100, this side by 100, even this side by 100, this side I now have percentage in S. I don't need to multiply this S the other side, not at all. Now I just need to substitute here. D is 2 over 200 plus T is 0.2 over 10.0. Then I'll multiply by 100 to change it to percentage. Pick your calculator, open the bracket, 2 over 200 plus 0.2 over 10, then multiply that by 100 to change it to percentage, and you will get 3%. So this is 3%. This makes the answer to be D. I think that is the end. I think that is the end. I hope there is no. Yeah, so that's the end of, that's the end of this. Thank you for watching. Thank you for watching. And have a good, stay safe.